Hello everyone, we are MassBuilders bringing to you our project, Intelligent Mobility. This is our team, and this is our co-designer, Caroline Hayes. She's an 85-year-old U.S. Air Force veteran. She's very social and outgoing and lives at Brightview Conquer Assisted Living Facility. She had some mobility challenges from osteoarthritis and partial blindness, and was very enthusiastic to talk to us about using science and engineering to improve her life.
Through interviewing Caroline and getting to know her daily routine, as well as her user needs, we found out to best create a product that meets her accessibility needs, we need to build something such that Caroline is able to move around with a wide range of motion while avoiding falls or tripping on a variety of surfaces. In addition, Caroline needs to be able to stop her rollator, which is a type of walker with wheels, more quickly without exerting a large amount of physical force. Last but not least, Caroline, due to her partial blindness, needs to be able to see her direction as well as her rollator in low light environments. As thus, we concluded that our objective is to design and build a rollator for elderly people that breaks easily and has greater visibility, making it easy to be seen. In the development planning phase, we settled on the two main features of automatic braking, controlled by buttons, that allow for the walker to be slow or completely stop, as well as a visibility feature that increases safety and rollator visibility and ease of being seen.
To develop our first prototype, we first had a CAD of Caroline's walker, and we found out potential spots to put a servo motor. And we made the first prototype to be out of a servo motor and some cardboard, and we used a solderless breadboard to wire it up. This is a video of our second iteration where we actually attached the motors onto the walker using screws.
So this is our user feedback and iterations. So first for the feedback, we had button placement issues, especially with Caroline. So we moved them from the lower handle where there was less thumb accessibility to the higher handle. The code was also not fault resistant, so we recoded it to be more resistant to faults and errors. Caroline also wanted the wires to be less visible so that it didn't come into contact with anything she needed to use. So we 3D printed a box to put it into the storage space so that she doesn't have to see any of the motherboards or anything else. Also, the power source wasn't enough to power the brakes, so we used two different power sources through two different batteries by switching them up and splitting them. So this is our hi-fi prototype. It had automatic braking, and through this we were able to use servo motor connection through 3 different connections: rotary actuator, precise, and torque servo motors. There's also blended wires with the chassis and split control of the brakes along with reflective stickers. All in all, this allowed for more visibility, durability, and maneuverability, and making it more ergonomic. All in all.
So this is a demo video of the high fidelity prototype with Caroline in the setting of her assisted living facility. As you can see here, Caroline just used the red button brake feature to bring the walker to a complete stop. She's restarting it, but has engaged the slow motion to move the walker ahead more slowly. The slow motion is split between 2 different wheels, so Caroline can slow down one wheel to make a turn.
So in the future, we hope to move the wiring to the chassis interior. We hope to switch to terrain wheels, which have more friction and traction, and fuse the power source / microcontrollers to a storage container for better durability. We want to avert potential product risk of inadequate user training with the buttons preventing it from being used properly, and avoid user rejection by placing the buttons near previous brake locations for better transitioning. And we have sent our walker to Caroline, and we'll be connecting with her outside of the project for more feedback. So throughout this project, we've learned that collaboration with a co-designer is essential in a user-centric design, that sophisticated features can often be replaced by simpler features, and that dividing feature development among sub-teams is very helpful. So let's work together to improve elderly mobility for a better life.
Thank you.